So the problem here is lowest common ancestor of a binary tree. In this problem, we're given a binary tree and we're also given two nodes. And we are supposed to find the lowest common ancestor of those two nodes in the tree. Let's understand what is an ancestor. Ancestor is nothing like any node that is above your parent. For example, for this particular node 8, this node 1 is parent, right? So any node that is above it or that particular node can be considered as ancestor for 8. So we are supposed to find the lowest common ancestor for two nodes that will be given in the question. Let's consider let's consider 6 and 4, these two nodes. So for these nodes, the lowest common ancestor would be 5. If we consider all of the ancestors for this node, it would be 5 and 3, but the lowest common would be 5. Okay, similarly, if we consider 0 and 5, let's say. So for these nodes, the lowest common ancestor will be 3, because 3 is the ancestor for 5 and 3 is also ancestor for 0. So now that we know what ancestors are, let's understand this problem with the given examples. Okay, so here we are given these two nodes, 5 and 1. For 5 and 1, we have to find the lowest common ancestor. So if we see here for 5 and for 1, for these two nodes, the lowest common ancestor is going to be 3. So that's the output. And for 5 and 4, for 5 and 4, the lowest common ancestor is going to be 5 itself, because 5 is an ancestor of itself, and for 4 also, 5 is an ancestor. So the answer is going to be 5. So what we're going to do, we will do a depth first search in this tree. We will start from this node 3 and we will keep on moving towards the child nodes to left and to right, and we will keep on doing that till we find these two nodes 5 and 8. And if we don't, if we end up at a leaf where these two nodes are not present, we will keep on returning null. And okay, so let me start here. From 3 we will go towards 5, and then from 5 we will check if this node is either equal to p or is it either equal to q or not. If it is, we're going to return 5 from here onwards. We will return back 5, and then we will again go in depth of 5 and check if we have 8 inside it, if inside in there. Okay, so for 6, no, it doesn't match p or q. Okay, never mind, we will go towards its left. What it is, it's null. Let me represent null by n. Then we will go towards the right of 6. Again, it's null. So here we will return null only. Okay, and then from 5 we will go towards its right. For 2, is 2 equal to p or q? No, it's not. Then we will again go to left of 2, and then 7 is also not equal to p or q. It will again go towards its children, and it will return null. And then for 2, we will go towards its right also. For 4, again null, as it's not equal to q anywhere. And then from here, 2 will also return null. But 5 itself is a root, right? So it will check if any of its children have any of these two nodes, p or q. It's not, but 5 itself is p, right? So it will return 5 back to 3. And then from 3, we will go towards its right. We'll check if one is either p or q. It's not. We'll go back. We'll go to its left child, 0, null, and then 0 will also return back null. And then from 1, we'll go towards its right child, which is 8, which is q. So now that we have found q, we will return back q only, which is 8. From here, we will return back 8. So the first node that has some value in left and right children, that whose left and right children's values are not null, that node will be our lowest common ancestor. Let's take another example. Okay, so in this example, let's consider our p and q to be 1 and 0. Okay, so for 1 and for 0, we'll start a depth first search from our root. It will go towards its left child, and from 2, it will go towards left child of 2. And from 1, it will go towards left child of 1, which is null, right child of 1, which is also null, and then it will check 1, which is indeed equal to p. So it will return the value of p only. Alright. And now from 2, it will go towards right children of 2. And then from 4, it will go towards left child null, right child null. And then from 3, we will return null only. But when we go towards 0, 0 will check its left child and right child also. And then when we come back, it will return 0. And then when we go back, it will return 0 only. So the first node, which has 1 and 0, is the lowest common ancestor. We know that. But how do we end this? We go back, it will return 2. Because this is the first node that has both a value in both its childs, right, left and right. And then from 6, if you want to go into the right child, null, null, back, null. So the answer is going to be 2. Yeah, so this is how it will work. Let's take a look at the code also. First of all, let's write simple function calls to go towards the left child, lowest. This is a simple recursive call to go towards the to go towards the left child of the root, and then we'll go towards right child. Now, if left child is null, what do? We return right. And in case right is also null, it will go as null only upwards. So we don't have to care about it. And in case left is not null and right is null, we will return left only. So this was the case if we had one value in one child. But what if we had value in both the child? Then the root is the lowest common ancestor, right? So if this case arises, we return root. Alright, now that we have given two recursive calls, we need to write a base condition also. So our base condition will be if root is either null or root is p or root is q, then we're simply going to return root. Yeah, so this should work.